Welcome to the SmartKeys podcast. Imagine a technician climbing a 200-foot ice-covered cell tower.
Oh, wow. In the dead of winter?
Yeah, exactly. In the dead of winter, just to check a bolted joint.
Huh.
Or, someone walking the edge of a high-voltage substation with a clipboard.
Right.
For decades, that kind of physical danger was just, it was considered the cost of doing business.
Yeah, just part of the job.
Exactly. But today, that entire process is being completely replaced by a robot that basically fits in the trunk of a car.
Which is, that represents a fundamental shift in how we think about corporate modernization.
Mm-hmm.
Usually when a company talks about, digital transformation, the assumption is that someone upgraded their CRM software or...
Right. Move some servers to the cloud or something.
Exactly. It's safe, it's contained, and it happens entirely behind a desk. But what we're talking about today is a digital transformation taking place hundreds of feet in the air.
Yeah. And that's why we're doing a custom deep dive tailored just for you, the professional, looking to stay ahead of the curve.
Absolutely.
Our mission today is to explore this massive shift from manual, dangerous fieldwork to, highly strategic commercial drone operations. We're basing this on a really fantastic guide called Commercial Drones: New Business Applications Taking Flight by Felix Römer from smartkeys.org.
It's a great piece. Really comprehensive.
Yeah, it is. So we're going to unpack the hardware, the software ecosystems, and most importantly, how your business actually transitions from treating this as like a sci-fi novelty to running a real profitable airborne operation.
And, the place to start that transition is definitely by looking at the immediate return on investment.
Okay.
Because before a company spends capital on aircraft, they really need to know what problem it solves right now. And the single biggest driver of ROI in this space is eliminating what the industry calls the truck roll.
Oh, the truck roll. I hear that term thrown around a lot in logistics.
Yeah.
A truck roll is basically anytime you have to dispatch a human being in a vehicle to physically go look at something, right?
Mm-hmm. Functionally, yes. That's exactly it. And if you break down the economics of a single truck roll, the costs are staggering.
I bet.
You've got the vehicle wear and tear, the fuel, the insurance, the hourly wage of the tech while they're just, stuck in traffic.
Right, paying them to sit on the highway.
Exactly. And then the actual time on site. But the heaviest cost, and honestly the biggest liability, is the physical risk.
Oh, for sure.
Sending a human being to walk a steep, slippery commercial roof to look for a leak, or having them hike along miles of remote pipeline.
Sending someone out with a clipboard to manually check a pipeline feels a bit like, it's like using dial-up internet to download a 4K movie.
That is a great way to put it.
It just seems like a massive misallocation of time given the tech we have now.
It really is. The dial-up analogy captures the speed difference perfectly, but it actually kind of understates the shift in capability.
What do you mean?
Well, upgrading from dial-up to broadband just meant you got the same movie faster, right?
Yeah, true.
Moving from a truck roll to a commercial drone doesn't just speed up the inspection. It fundamentally changes the type of data you can collect.
Okay, give me an example.
Let's take commercial agriculture. A farmer could spend a week driving the perimeter of a, say, 5,000-acre farm, just looking for signs of crop stress.
That's a lot of driving.
Right. But by the time the stress is actually visible to the naked eye from the ground, the crop is usually already failing.
Because they're only seeing the outer edge of the field, like at ground level, just in the visible light spectrum.
Precisely. But an airborne platform equipped with multispectral sensors can sweep that entire 5,000 acres in a fraction of the time.
Wow.
And it's analyzing how the plants reflect near-infrared light.
So it sees what we can't see.
Exactly.
Yeah.
It identifies localized nitrogen deficiencies or pest stress weeks before a human on the ground could spot it. You document the exact coordinates of the problem, apply chemical inputs only to that specific half acre.
Instead of spraying the whole farm.
Right, instead of blanket spraying.
Right.
And you drastically boost your overall yield while saving money on chemicals.
That's amazing. And public safety is another arena where this just, completely changes the paradigm.
Oh, absolutely.
Like, think about a hazardous material spill on a highway or a massive structural fire. The traditional response is pulling up in an engine and trying to assess the situation from eye level.
Which is basically guessing what's happening in the center of the chaos.
Yeah, exactly. Gaining rapid overwatch and clear situational awareness from the air before sending emergency crews into a hot zone, that isn't just an efficiency upgrade. That is literally the difference between life and death.
It really is. The value proposition is undeniably clear across almost every physical industry. But this leads directly into the biggest hurdle for businesses trying to adopt the tech.
Which is?
How do you actually choose a platform? Because the consumer tech mindset, where you just buy the latest gadget and figure out how to use it later,
Right.
that will absolutely sabotage a commercial drone program.
Well, let me play devil's advocate here for a second.
Sure, go for it.
I see these massive enterprise drones, and honestly, it looks like overkill. If I'm running a commercial roofing business, why can't I just buy a $1,000 consumer drone from a big box store?
I hear that all the time.
Right, like it has a 4K camera, it flies. Shouldn't a business just buy a high-end consumer model and be done with it?
That is the trap so many businesses fall into. And it really comes down to a misunderstanding of what we call payload headroom and environmental resilience.
Payload headroom.
Yeah. So a consumer drone has a permanently attached camera. It's a sealed, closed system. If you buy that, you are locked into that exact camera forever.
Oh, I see.
But in the enterprise space, your needs evolve constantly. Today, you need a high-res camera to map a construction site. Next month, you might need a laser scanner to map terrain.
Right, right.
Next year, you might need an acoustic sensor to listen for pressurized gas leaks along a pipe.
Okay, so payload headroom means the aircraft actually has the physical lifting capacity, the power output, and the open digital architecture to let you swap those different tools in and out.
Exactly. You are not buying a flying camera. You are buying an industrial flying tripod.
An industrial flying tripod, I like that.
Yeah. And that requires moving out of the consumer mindset and looking at the tiers of enterprise hardware.
So what are the tiers?
You generally have three main ones. First, you have the compact trunk-to-takeoff tier. These are frames like the Autel EVO2 lineup, which cost roughly between $2,000 and $5,000.
Okay.
They fold up, they sit in the trunk of a police cruiser or a site manager's truck, and they can be in the air in under a minute.
And even at that enterprise tier, you aren't just getting a basic camera, right? Like you can get a unit with an integrated thermal sensor.
Yeah, absolutely. Like the dual 640T V3, it's around $4,799, and thermal is just invaluable in those rapid deployment scenarios. But when you step up from that compact tier, you enter the heavyweight workhorse category.
The big guys.
The big guys. This is your $12,000 to $15,000 investment. Platforms like the DJI Matrix 350 RTK, these are built to stay in the air all day, cycle after cycle. They have dual battery setups.
Now, I would imagine 2 batteries just means it flies twice as long, right?
Well, it does extend flight time, usually pushing it to that 40 to 45-minute mark per sortie. But the real reason for dual batteries is redundancy.
Oh, really?
Yeah. If you have a $30,000 laser scanner mounted to the drone and you're flying over an active construction site, a single battery experiencing a sudden voltage drop is catastrophic.
Oh, man, yeah. The whole thing just drops out of the sky.
Exactly. With the dual setup, if one battery fails, the second immediately takes over and brings the aircraft home safely. They also feature hot swapping.
So you don't even have to turn it off.
Nope. You land, pull out the depleted batteries, slide in fresh ones, and take off again without ever powering down the aircraft or rebooting your mapping software.
Wow. That makes total sense for a continuous workflow. But I also noticed these heavyweight enterprise models boast redundant IMUs. What exactly is an IMU, and why does a business owner need to care if there are 2 of them?
Good question. So IMU stands for Inertial Measurement Unit. Think of it as the inner ear of the drone.
Okay, the inner ear.
It's the sensor array that tells the flight controller which way is up, how fast it's accelerating, and what angle it's tilted at.
Makes sense.
But if a drone flies too close to a massive steel structure like a bridge or a transmission tower, the magnetic interference can severely confuse a standard IMU.
Oh, I hadn't thought of that.
Yeah, the drone essentially gets vertigo. It might just flip upside down and crash. Enterprise models have redundant IMUs shielded against interference, so if the primary inner ear gets confused, the backup instantly cross-checks the data and keeps the platform stable.
Okay, so you have the compact tier for quick deployment, the heavyweight tier for carrying expensive sensors all day, and then you have the heavy lift tier. These are the absolute beasts of the sky, designed specifically for things like agriculture. We're talking about demo frames, roughly around $3,500, that can carry payloads of 22 pounds or more.
Oh, yeah. The physics of flight at that heavy lift tier get incredibly demanding, especially when you are moving liquid.
Liquids.
Yeah. If you have a drone carrying a massive tank of liquid fertilizer or fungicide, Think about what happens as the drone maneuvers over a field and sprays that liquid.
Well, the tank is constantly emptying, so the weight is dropping.
The weight is dropping, yes, but more importantly, the liquid is sloshing around.
Oh, right.
Every time the drone banks to turn around at the edge of a field, 20 pounds of fluid rushes to one side of the tank. The center of gravity is violently shifting from second to second.
That sounds like a nightmare to fly.
It is. The flight controller has to perform incredibly complex mathematical adjustments to the motor speeds in real time just to stop the drone from ripping itself out of the sky. You simply cannot do that with a retrofitted consumer drone. It requires purpose-built, heavy-lift engineering.
Okay, so we've established the aircraft. We have the ultimate flying tripods. But the drone is just the delivery vehicle.
Right.
The actual product that a business is paying for is the data. So what are we mounting on these tripods to get that data? Let's talk about the sensors.
Well, the specific sensor entirely dictates the outcome. The baseline is a high-resolution RGB camera, essentially a highly calibrated, standard, visible light camera. These are used primarily for photogrammetry.
And photogrammetry is when the drone flies a grid pattern, takes thousands of overlapping flat photos, and then software stitches them together to create a 2D map or a 3D model, right?
Correct. It matches the pixels from different angles to understand depth and surface texture. It is phenomenal for mapping an open construction site or measuring the volume of a dirt stockpile.
Okay, so what's the catch?
The limitation is that photogrammetry relies on visible light. If you're trying to map the ground in a densely forested area or trying to find the structural base of an overgrown cell tower, photogrammetry fails.
Because it just sees leaves.
Exactly. The camera just sees a sea of green leaves. The software cannot stitch together what it cannot see.
And that is where LiDAR comes in.
Yes.
But how does LiDAR manage to see through the trees?
So LiDAR stands for light detection and ranging. Instead of taking passive photos, a LiDAR sensor actively fires hundreds of thousands of laser pulses every single second down at the environment.
Hundreds of thousands.
Yes, every second. Now, it doesn't magically make the leaves transparent. Many of those laser pulses will hit the tree canopy and bounce back. But because it's firing so fast, a fraction of those light pulses will slip through the microscopic gaps between the branches and the leaves, hit the actual ground, and bounce back to the sensor.
Wow. It's basically playing a massive game of probability with light.
That's exactly what it is. The software strips away the first returns, the leaves, and leaves you with a perfectly accurate, bare earth 3D model of the ground beneath the forest. It is a total game changer for land surveying, pipeline routing, and search and rescue.
That's incredible. And we touched on thermal imaging earlier, but I want to dig into the mechanics of that.
Sure.
If I'm managing a massive commercial facility with acres of flat roofing, how does a thermal camera find a water leak? You can't see water through a rubber roof.
Well, you aren't looking for the water directly. You are looking for the thermal signature of the water.
Okay, how does that work?
Water is incredibly dense and retains heat much longer than standard roofing materials, so the strategy is to fly the drone just after sunset.
Ah, I see where this is going.
Yeah. The sun goes down, and the dry areas of the roof rapidly cool off. But the area where moisture is trapped underneath the membrane holds on to that solar heat for hours.
So it stands out.
Exactly.
Right.
Through a thermal camera with, say, 640 by 512 resolution, that hitting pocket of water will literally glow bright orange against the cool, dark background of the dry roof. You can pinpoint a leak down to the square inch without ever stepping foot on the building.
That is brilliant. But here's a critical point about all of these sensors, LiDAR, thermal, high-res cameras. The data they collect is entirely dependent on the drone knowing exactly where it is in the sky, right?
100%.
If you're building a 3D model of a bridge and the drone drifts in the wind by a few feet while it's taking photos, your entire 3D model is warped. How do these enterprise systems stay perfectly locked in place? I mean, everyone has GPS on their phone, but my phone still occasionally thinks I'm driving in a river when I'm on the highway.
We've all been there. Standard GPS is an absolute marvel of engineering, relying on satellites orbiting 12,550 miles above the Earth.
Wait.
But you are right, it is only accurate to within a few meters. When your phone navigation looks flawless, it's because the software is cheating.
Cheating.
Yeah, it knows you're probably in a car, so it mathematically snaps your location to the nearest road on the map.
Ah, so it's faking the precision.
Yes. But when a drone is 200 feet in the air over a featureless field or a complex industrial site, there is no digital road to snap to. It's relying purely on the raw satellite data, which means it can drift by 3 to 10 feet.
And that drift ruins surveying data.
Completely. The solution is RTK, or real-time kinematic positioning.
Okay, how does RTK fix the drift?
It introduces a fixed point of reference. You place an RTK base station on the ground over a known surveyed point. That ground station listens to the same 20-plus satellites the drone's modern receivers, like the U-Block's F9P, are listening to.
Right.
But because the ground station knows exactly where it is on Earth, it can calculate the microscopic timing errors in the satellite signals caused by the atmosphere. It calculates that error and beams a continuous real-time correction signal directly to the drone.
So the drone is getting the satellite data plus a cheat sheet from the ground telling it exactly how far off the satellites are.
Precisely. That combination boosts the positional accuracy by 10 times. We're talking about going from a margin of error measured in meters down to a margin of error measured in centimeters.
Wow, it's like the difference between giving someone directions like the leak is somewhere on the north side of the roof versus giving them the exact coordinates down to the millimeter.
Exactly. And that level of absolute precision fundamentally changes pilot behavior. With that centimeter-level lock, commercial software allows pilots to engage what are called velocity clamps.
Velocity clamp.
Yeah, a pilot can cruise quickly between inspection sites and then dial the maximum speed of the drone down to exactly 0.1 meters per second.
0.1 meters per second. That is basically a slow crawl for delicate camera alignment.
It is. It allows the drone to hover in the exact same centimeter of space in the sky. And more importantly, it ensures repeatability.
What do you mean by repeatability?
If you inspect a cell tower today and then come back in 6 months to check if a crack has widened, the RTK system ensures the drone goes back to the exact same point in three-dimensional space, pointing the camera at the exact same angle. That repeatability is what makes the data legally and technically reliable for engineers.
Okay, so we've built the ultimate operation here. We have the heavyweight platform with redundant IMUs. We have a LiDAR payload. We have centimeter-level RTK precision. The drone flies the mission perfectly. But what happens next?
The hard part.
Right. What is the biggest bottleneck for a company trying to scale this up? Is it training the pilots, or is it managing this massive fire hose of data they bring back?
Oh, the data pipeline is absolutely the make or break point for scaling. Capturing perfect data is useless if it just sits on an SD card in a pilot's backpack.
Yeah, that helps no one.
A business needs a standardized workflow. It starts with pre-flight planning and mission software, so the flight path is automated. Then the drone flies, and the onboard RTK system physically geotags every single image or laser pulse with that precise location metadata.
And if the pilots aren't disciplined about file management?
Total chaos. If you have 15 pilots and they all just let the camera name the files IMG001, you will inevitably overwrite critical data or lose track of which photos belong to which site.
That sounds like an expensive mistake.
It is. Standardizing naming conventions and export rules before the drone ever leaves the ground is critical. After the flight, that data needs to flow seamlessly into processing software to build those 3D models and then immediately push to a cloud delivery system so the stakeholders, the engineers, the project managers, the farmers can actually look at it and make decisions.
Right. And beyond managing the data, there's the challenge of managing the physical fleet and the humans flying them.
Yeah, that requires dedicated fleet management software. When you scale up, you need a centralized dashboard tracking the health of every single battery, the maintenance intervals for the aircraft motors, and the exact flight hours of every pilot.
And logging those pilot hours isn't just about internal metrics either. That brings us to the regulatory environment. Because the FAA is not playing around when it comes to commercial airspace compliance.
Not at all. In the U.S., any commercial operation requires the pilot to hold a Part 107 certificate. But the regulations get incredibly complex when you want to execute advanced operations like BVLOS.
BVLOS, beyond visual line of sight.
Right. Historically, a pilot always had to be able to see the drone with their naked eye. But if you want to inspect 50 miles of power lines, you can't walk behind the drone the whole way.
No, of course not.
You need permission to fly it miles away, beyond your visual line of sight. Getting a BVLOS waiver from the FAA requires proving you have bulletproof data links, radar systems to detect other aircraft, and incredibly strict operational protocols.
This sounds like a massive administrative lift for a company whose primary business isn't aviation. If I run an engineering firm, I don't want to build an aviation compliance department from scratch.
Which is exactly why the prevailing advice for enterprises is to avoid cobbling together consumer parts or trying to build the ecosystem in-house. You want to work with authorized, seasoned distributors who specialize in commercial integration.
Like who?
Firms like DSLR Pros, for instance. They've been building these ready-to-go solutions since 2012.
Oh, wow. So sourcing from an integrated partner means you aren't just buying hardware. You're getting the aircraft, the certified third-party sensors, the cloud software architecture, and the regulatory assistance all aligned in one package.
Right. It also ensures you get proper system-specific training. I know some of these partners even provide dedicated Spanish language support, ensuring that the actual crews in the field are fully trained and included in the deployment.
That's huge. Sourcing a cohesive ecosystem must drastically minimize the time it takes to get from the initial purchase order to actually generating profitable data.
It absolutely does. It removes the guesswork out of compatibility and compliance.
Which brings us to a final practical takeaway for you, the listener, as you look at bringing this capability into your own organization. The overarching philosophy here is to start small, scale smart.
Definitely.
You don't need to buy a fleet of 10 heavy-lift drones on day one.
Yeah.
You can invest in a single demo frame to prototype your sensor mounts, validate your spray patterns, and stress test your data workflows. Prove the concept, standardize your settings so your reports are consistent, and then expand.
And ensure you budget for the unglamorous realities of aviation. The spare props, the extra batteries, the solid charging strategies, because those are the things that keep an operation running steadily day after day.
As I look at all of this, the payloads, the LiDAR, the centimeter level precision, I can't help but think about where this is heading in the next 5 years. As these drone platforms become as standard and ubiquitous as a company laptop or a fleet vehicle, the true competitive advantage for a business won't actually be owning the best drone.
It becomes a baseline expectation, not a differentiator.
Exactly. Everyone will have the hardware eventually. The real advantage will be how seamlessly a company can automate the flow of that physical field data directly into their AI and business intelligence software without any human intervention at all. The drone stops being an aviation project and simply becomes a silent, flying node in a massive network of data collection.
The hardware disappears into the background, and the automated, actionable insight becomes the actual product. That is the ultimate destination of this technology.
Something to mull over as you think about how your own industry is evolving. We have gone from the expectation of staring at a digital dashboard on a desk to deploying precision robots 200 feet in the air, transforming the physical world into actionable data. Thank you for tuning in to the SmartKeys podcast.
It has been a pleasure to break this down.
Make sure to subscribe to the podcast so you never miss a deep dive into the trends shaping the future of work. And if you want to explore the specific tiers of hardware, the payload mechanisms, and the software workflows we discussed today, you really should read Felix Römer's full article. We have placed the link to the comprehensive guide over at smartkeys.org right in the show notes for you. Until next time, keep looking ahead.